Hello guys, in this video let's measure the performance of belongs-to-many relationship versus polymorphic relationships. So polymorphic are more flexible for the future, but they are by definition a bit slower. But by how much? So I decided to measure, and in this video I'm showing cursor, not my regular PHP storm, because cursor partially helped to generate that situation with seeding the data and the benchmark script. And let me know as a video viewer whether you prefer cursor or PHP storm, just how things look on the screen. Anyway, so we have the post model and also we have course model, and both with the same thing, tags and polytags relationships. In the database, we have 50 random tags, we have 50,000 random courses, and 50,000 random posts, both having 1 to 10 random tags, so 200,000 records in the post tag table, and roughly the same amount in the course tag table. But also there's a table tagables for polymorphic relationships. So for each record, there are both belongs-to-many and polymorphic. And let's benchmark querying the data from different angles and also inserting the data, which is faster and by how much. Also for the record, I will show the migration. So this is for an ID for post and tag. This is a pivot table for post tag, also roughly similar for course tag. So this is a typical pivot belongs-to-many. And then for tagables, we have this polymorphic relationship with also primary key and index for faster lookups. And this is our artisan command to benchmark, partially generated by cursor and Claude, but I've made some manual changes. So the main thing that you need to know is this benchmark measure. There's a feature in Laravel, not sure if you're aware, and then you have array of keys and callback functions, what to do with that key. And in this case, each benchmark method in that list does something like this. Just taking the data from the database, post with this, post with that, then the same courses, and we have iterations parameter, which is by default 100 records. And then what about getting one random record for post and for courses, all for both types of relationships, belongs-to-many with tags and then polytags, and then from the other way around. Get the related record for the tag. For example, you have a page where you show all the record for the tags. Then this one is the slowest because we have 50,000 records, so just the amount of data will be slow. It's probably not a realistic scenario, but we will measure kind of apples to apples. So the same scenario, the same slower scenario with both belongs-to-many and polymorphic. Also, we're benchmarking inserting the data, so sync without detaching, sync and detach. So these are protected functions, but the main thing is this benchmark measure. And let's see what happens. Let's run the command. Starting benchmarks, and in a few seconds, this is the result. This is, by the way, the result of benchmark measure, and actually let's take a look at how the data is presented. So benchmark measure returns the collection, and by the way, each method is run 10 times. This is the second parameter of benchmark measure, and then we show the table in the terminal with formatting benchmark results like this. So have collection and then map and returning name and value. A bit more complicated collection chain, but it works brilliantly and shows us that table. Now let's analyze. What do we have here? First, fetch posts with tags, which is those two functions, tags versus polytags, and the result is 8 milliseconds versus 11 milliseconds. So for this case, polymorphic relationships are around 40% slower, I would say. Then fetch courses with tags, same thing, 10 versus 13 milliseconds, so 30% slower for polymorphic. Then fetch tag for a single post. These are very fast queries, so it's not even worth discussing the difference. Then this difference, fetch posts and courses for the tags. This is the thing that I told you it will be the slowest. These two functions, so they are slow just because the amount of related data, but the difference is roughly similar, 20 to 30% roughly slower. And then attaching and detaching, also they are pretty fast, so not worth really comparing those two. So what conclusions can we make from that? If you have polymorphic relationships, of course you have flexibility. So if in the future you have third model to attach to, like for example video tags or photo tags or tags to users, then you have that flexibility because you don't need to change the database structure. You just add more data to taggables table here. But with that, if you want to query the data, you have slight performance disadvantage. So queries may be slower by 20 to 40%, as you saw in this video, but also maybe your scenarios would be not exactly the same ones as in this case. So maybe you would optimize limiting the data to query by, or maybe you will just query from different angle altogether. But in this video, I wanted to satisfy my own curiosity actually. What would be the exact numbers? So not sure. Can we make some real conclusions from this? Let's discuss in the comments below. And if you want to dive deeper into structuring the database with various relationships, I have a separate course called Structuring Databases in Laravel 12, where I discuss all those relationships, what are their pros and cons, and also other structures like UUIDs, JSONs, enums, custom fields, and other stuff. I will link that course in the description below. That's it for this time, and see you guys in other videos.